Okay, let's jump right into it today. We're doing a deep dive, really getting into some fundamental ways we make sense of, collections of numbers.
Right. Think of it like understanding the essential tools you need for looking at any set of data. Our source material is a great guide here.
Yeah, it walks us through the big three: arithmetic mean, mode, and median. Simple ideas maybe, but powerful.
Definitely. They each give you a different kind of snapshot of your data.
So where should we start? Maybe the arithmetic mean. That's the one most people know as the average.
Yeah, let's start there. And in its simplest form, for just raw data, it's exactly that. You add up all the numbers you have,
Right.
and then you divide by how many numbers there are. The source uses that notation, 6n.
Sigma x over n, sigma just meaning sum of.
Exactly. Sum of all the x values divided by n, the count.
Like in that example they gave, 7, 10, 15, 11, and 9.
Perfect. Add those up. What is that, 52?
Yep, 52.
And there are 5 numbers, so 52 divided by 5 gives you 10.4. That's your mean.
Yeah.
Pretty straightforward.
Okay, but what if the data isn't just a raw list? What if it's like already organized, say, in a frequency table?
Good question. The idea is the same. Find a typical value, but the math changes slightly. Instead of adding 15 3 times, if it appears 3 times,
Like,
you just multiply the value 15 by its frequency, 3. You do that for each value.
so value times frequency.
Exactly. Then you sum those products up, that's your FFX, and you divide by the total number of data points, which is just the sum of all the frequencies.
Ah, okay. Still total value divided by total count, just calculated efficiently.
Precisely. The source has an example with values 10, 15, 20, and so on with their frequencies, leading to a mean of 21.75, I think it was.
And for group data, like data in ranges 20 to 30, 30 to 40, that kind of thing.
Right, class intervals. There you have to approximate a bit because you don't know the exact values within each group.
So what do?
You find the midpoint of each interval. So for 20 to 30, the midpoint is 25. You basically treat all the values in that group as if they were 25.
Okay, sort of an assumption.
It is. Then you use that midpoint, just like you use the value in the frequency table.
Mm-hmm.
Multiply the midpoint by the frequency of that group, sum those up, and divide by the total frequency.
Got it. So mean is pretty flexible. Now, there was this really interesting property mentioned about changing the numbers.
Oh, yeah, that's a neat one. If you have a data set with a certain mean, let's call it m, and you add the same number, say x, to every single value in your data set, the new mean just becomes the old mean plus x, so m plus x.
Simple as that.
Simple as that, and same logic for multiplication. Multiply every value by x. The new mean is the old mean times x, so m times x.
Wow. The source example was great.
Yeah.
Mean is 20. Add 5 to everything. New mean is 25.
Exactly, or multiply everything by 2. New mean is 40.
Yeah.
It shows how the mean directly reflects those uniform shifts or scaling in the data. Very handy shortcut sometimes.
Okay, totally shifting gears now. Let's talk about the mode. Sounds simple.
It really is. Conceptually, the mode is just the value that shows up most often. It's about popularity, not magnitude.
So if you have that list like 15, 20, 15, 30, 20, 20, you just count.
You just count. In that example, 15 appears 3 times, 30 twice, but 20 appears 5 times.
5 times, yeah.
So 20 is the mode because it's the most frequent.
And if the data is already in a frequency table?
Even easier. You just scan the frequency column for the biggest number. Whichever value corresponds to that highest frequency, that's your mode. The source had one where 14 had the highest frequency, 30. So the mode was 14, instant.
Okay, mode most frequent, got it. Finally, the median, the middle ground.
The middle ground, exactly. But there's a critical first step here. Can't forget it.
What's that?
You have to sort the data first. Put it in order, smallest to largest, or largest to smallest. Doesn't matter which, but it has to be ordered.
Right, okay. Order is key. Then what?
Then you find the middle value. If you have an odd number of data points, it's easy. There's one number smack dab in the middle.
Like the example, 8, 9, 10, 12, 13, 15, 17. Sorted. The middle one is 12.
Bingo. 12 is the median. Half the data below it, half above it.
But what if you have an even number of data points? There's no single middle number then.
Correct. You'll have 2 numbers right in the center after sorting.
Like in the source's other example, with 10 numbers, the middle 2 turned out to be 9 and 8 once sorted.
Right. In that case, the median is the average of those 2 middle numbers.
So you add them up and divide by 2. 9 plus 8, 2.
Which is 17 divided by 2, giving you 8.5. That's your median. It's all about the central position.
So mean, mode, median, they all seem to represent the data somehow, but they're clearly different things. Why should you, the listener, care about knowing all three?
Well, because they give you different kinds of information. The mean is your typical balance point, but it can be pulled around by really high or low values. The mode tells you what's most common, which might be totally different. And the median tells you the exact center position, ignoring extreme values. They paint different pictures.
Which leads us to a final thought, something for you to chew on based on what we've discussed.
Yeah, think about this. Since the mean, mode, and median can all be seen as ways to find an average or represent a data set, when might one of these measures give you a really different story? Maybe a more useful story, or maybe even a misleading one compared to the others, something to ponder when you next look at a set of numbers.